Hi everyone, this is Alan Ching. Today I will present the EEC10 final project to you, which is a signal and analog system. So this system can do the sound localization based on and the serial model will point to the direction where the sound source comes from. And meanwhile, the system on the VI will also give you ability to either record the sound and set the time to record the sound at a specific time when the program is running. Moreover, you have the ability to select the range of the filter to decide the range of the frequency you want and through the VI. Okay, let's go. Let's see how it works. Okay, let's take a close look at this system. So we have MyDAC. MyDAC will deal with the signal that were recorded through those two microphones. And this will send the message to the computer. The PC will deal with the signals and send the string, which is a degree message, to the microcontroller. And the microcontroller will control the server model, which point the direction of the source. All right, let's look at how it works. Okay, now we run the VI. So I have set it the noise level, which the speaking now will be treated as noise. And now we will click the hand to make the high peak value, and the server model should point at the direction as my sound comes from. Okay, let's take a look. Okay, let's try the middle side. Perfect. Let's try this side. It works. So that's how it works to find the localization of the sound. And here is something way more cool. Here we go. So as you can see, when I move the sound of the music, the server model will change the direction of the pointer to point the sound source. Alright, here is how this final project should work. And now, next, let's take a close look at the code. Okay, here is the VI. So basically, this one will give you ability to choose the microcontroller and to write as through the VISA. And this two channel is amplitude as respect to time of the two microphones. And this is a filter. As you can see, you can select the volume and the filter to change it as you want. And this is a time, which when you do the time recording by clicking here, then this time will run the current time, and you can set up time by clicking this guy. And when the time reaches that point, it will start recording. So when you want to turn it off, just click it. Moreover, here is record. Record gives you more flexibility as the time you want to record just by clicking it. As now my voice has been recorded, and you can click turn it off as anytime as you want. So then it will stop at there. And this is the address of the audio. So just copy paste to the library, to the folders, and basically you just play the sound you want. Okay, that's the front panel. And let's look at the back panel. So how I do it is pretty easy. So basically this part is for the recording. As I initially set the file of the recording files. So that's a format. The 44100 is a frequency that the file should read and record. This is the same as the frequency I put it in the MyDAC. So if you set this number different than MyDAC, you will receive different audio files. So for example, I set it half frequency as now before, so the audio output will be super slow like this. What? So that's an example. Okay, so let's look closer. So this is the filters. As you see, the filters. This is the low pass. This is the band pass, and this is the high pass. They will select. Keep the frequency that you want as you set. So meanwhile, and here is what I do. So I separate the two signals to left channel and the right channel and transfer them to an array. So I compared the time differences, all the phase differences to determine the angle that the server model should shift. So here's what I did. So I found the maximum values index with of different both channels, the microphones, and I minus the differences as you can see here. So and then I times a constant. So and this constant will determine the angle, and plus 90 will be the final angle I use. So what this 12.1 doing here is select the value. So the differences sometimes can go over through more than 1,000. That's not what we want. So I tested this number by clipping my hand on either side, and this number should most frequently, and that's the reasonable number I know which I should pick. So as you see, I use the absolute value of these differences. Okay. So what the noise elimination, as I explained, as I mentioned before, this will determine the what level amplitude of noise you treat as noise. So you have ability to set it in the front panel, and what here do is get the maximum value of either one and compare this maximum value with this one. The maximum value has to above this noise elimination to be treated as reasonable and valuable signals. Then this will return true. When this returns true, the whole writing diagonals of the angle will running. If it's forward, then I do nothing. Okay, here's how. And this is the recording. So basically just record, and that's the time recording by which you click that is true to run this one. So we first get the current time and then compare with the start record time. So when the current time is bigger than the start record time, bigger or equal, then this return true for the audio to recording. Or there is another one is you can record whenever you want. Just by clicking this record button, when it returns true, this will return true. This is all buttons, so either one is true, the audio will be recorded. And in the end, out of the while loop, I close the file to save the file. And since the path is generated by this one, this will generate a default and random audio path as you saw before on the front panel. So okay, so overall, this program works pretty well. The noise elimination gives you more ability to decide what kind of amplitude you really want, and also works in various environment. And this also worked pretty well, as you see. While speaking during this audio, the server model still judges angle. As I move more close to the right hand side, this will move to the right side. So you see, works pretty well. And just one last hint: instead of comparing the time differences or the phase differences, you have two more ways. One is cross correlation, or one is comparing the amplitude. So here is all the descriptions of my final project. Hopefully it's helpful for your final project. Thanks. Bye bye.